use these commands to install the PyCaret library inside your working environment. Okay? So how you will extract the data set from the dot operator? You will use the data set, okay, and import this data set, okay, using the method get underscore data. Okay, so yes, so first line of code is this, and execute it. After this, what you will do, you will get that insurance data set as you have said in the chat that we will use this get underscore data to access the data set, that is a insurance data set. So you will see right here, insurance data set contain these folders like age, sex, BMI, children, smoker, region, and charges, whereas these are the rows of this particular insurance data set. Okay, so how you will give the insurance to particular person, that will depend upon the factor of these columns which we are representing. Okay, now what we will do, we will create regression model. Okay, we will create regression model. So how you will call the regression model? You will use from PyCaret, then you use dot operator. After dot operator, you have to use the keyword regression. Okay, so after executing this, we have imported all the regression models. Then what we will do, we will create a setup function. Okay, we will create a setup function to define the data as well as to define the target. Okay, so firstly, the data set which you have imported into the variable, that is the insurance data set, you have to use this for the data set assignment. Okay, so for that we will create a variable s. Okay, so in this s variable we define a setup function and we assign a data, that is insurance data set, which we have taken from here using get underscore data, and we define a target. Okay, so what is the target? Target is the last column. Okay, this is the target, charges, this is the target. We have to predict the charges, okay, for the insurance. So this is the target, and silent we have put as a true. That means it will not give you the runtime output, and it will give directly the final output right here. Okay, so execute this line of code. After executing, you will find that all the data sets, okay, all the algorithms which we defined right here, that will be provided to this particular set of function, and this s variable contain all the values. Okay, so you will see the output right here. So all the data which is present right here will be compared with the learning algorithm, that are k nearest neighbors, elastic net, passive aggressive regressors, then orthogonal matching results. Okay, and least angle regression. So all these algorithms are evaluated and compared with the with the created model. Okay, so after creating this particular model, we have compared all the values with the existing data, and then what we will do after this, we will apply some normalization methods using this Yo Johnson method. Then I will put this transformation methods uh, right here, okay, inside this single inverted commas. So transformation is also true. Normalization we have used as a z-score, and after this, you can see we have used silent equal to true. Okay, normalization method, outlier removal. Okay, all these parameters we have passed right here. compare this model. So you will see the output right here for the comparison. You can see right here. So for creating this random forest model, we have to first use the dataset dataset, okay, and we have to extract that data using get underscore data. Then we have to use this keyword, that is a regression, and we have to import all the regression model. Then we have to extract this data using get underscore data function. So I am extracting right here Boston dataset into the variable Boston dataset. After using this, we have defined a setup function, and you can apply this Boston dataset right here. And so execute this line of code, and after executing, you will see our model is created. Okay, so I have written all these values right here. The next task is we have to save this trained model. Okay, next task is we have to save this particular model. Save underscore model function. Okay, we have to use save underscore model function and save your model. After saving this model, we have to again load. Okay, why we are performing these operations right now? You can see when you want to create some model at particular time, and you will not get that much good results at that particular time. Then what you will do in a later time, when you come up with some idea that this particular model is to be applied in such a manner that it will give you a 100% accuracy, you will use that model in a later stage. Okay, so you store that model with the file name, that is a RF model file, and you have to extract that file in a later stage. Okay, so how you will extract this particular file in the later stage? You have to use the function name. What is the function name? Load underscore model. Okay, and apply the file name right here. Okay, so what is the file name? RF model file. This is the file name which we have used right here. So we have used this particular model, and now we will perform some task on this particular data set. What is this one which we have shown right here? This is the actual output. After creating a model, you will get the output. Okay, and this random forest will give you the output right here, and inside that we are using the old model, that is RF model, which is stored right here. Okay, this is the RF model which we have created. Okay, this is the initial one. Okay, so on this particular RF model, we have to create the prediction. Okay, so we have to take the input as a new data set. Okay, so how you will take a new data set input? So similarly, we will take few values from the existing data set, or few columns or rows from the present data set. Okay, so firstly, you have to take the input. Okay, so how you will take the input? So this is the Boston dataset we have used, and inside this Boston dataset we are accessing the file locations, or these row locations starting from 0 to 10. So first 10 values we are taking. So 0 to n minus 1 location means 0 to 9 value, that is 10 total values we are accessing. Okay, so you will see Boston dataset is present right here. Okay, we have used this Boston dataset. This is the Boston dataset. Okay, so 46 serial number is there in the PyCaret library. Okay, so firstly, you will see this data set we have taken, that is shown right here. Okay, after that we are using this predict underscore model, and we are predicting the output for this particular data set. Okay, so these are the outputs which is shown right here, and you will compare these output with the previous output which you have shown right here. Okay, firstly we will create a random forest model, and then we will plot all the graphs related to that random forest model. Create underscore model is used to create a model. And what is the short form of random forest model? RF is the short form. So RF model is created right here. Execute this. You will see this model is created with all the parameters. Okay, now what we will do after creating this particular model, we have to plot the RF model's errors, okay, which are present. So how you will plot this? You have to use RF underscore model, and inside that RF underscore model, you have to define the model name. So what is the model name? Model name is RF. Okay, and inside the function you have to use the plot function. Okay, so plot is equal to give the keyword of the particular graph. Okay, so right here I am using the keyword error. Okay, so that means we have to plot this error curve, okay, for this new RF model. Okay, so I will execute this line of code and you will see the output. Okay, so what is the best fit, what is the identity, what is the R square value, they are represented right here. Okay, okay, so we are just using the same code, but we are replacing right here plot value. Okay, so instead of errors we have to change this value to the learning. Okay, so right here the keyword learning. Okay, so with the help of this learning keyword you can plot the graph for the given model, how it will learn the outputs. Okay, so perform this operation right now, and you will see the output of the learning curve. So learning curve will be represented in training instances and the score of its learning. Okay, so you have some cross validation score, and you have some training score for the random forest model. So you will see these two curves will be shown inside this particular learning curve. Okay, so it will take some time to process the data because it has to plot the learning as well as the training scores. Okay, and the validation score. So you will see right here these green dots which are represented right here, they are cross validation score. So what is validation score? I have told you that in in the time of testing, okay, in the time of testing you have to give unseen data to the model, and that unseen data is to be correctly predicted. Okay, so the correctly predicted values are shown like this. Okay, so what is the score of your model right here? Up to 82% it will give you the accuracy. Okay, but in case of training score you will see your accuracy is 100%. Okay, 95 to 98 and 99% accuracy you are achieving with the help of this training data. But in case of testing you are getting up to 82 or 83% accuracy. Okay, so you will see this is the training instance, that is how much training data you are providing. So 100 samples are there, 150 sample, 200 sample, 250 sample, 300 sample, and up to 350 samples you will provide to this particular random forest model for the given data, and it will give you the accuracy like this. Learning, we are replacing it by VC. VC is the keyword for validation curve. Okay, so you will execute this line of code, and you will see the graph in between the cross validation score and the training score of actual estimated maximum depth of that value and the score of the given data set. Okay, so it will take few minutes to process this training as well as validation process, and it will plot all the data points between actual estimators and the scores. Okay, right here. Okay, so what is the output it is showing? It is showing in green color. These dots represent the cross validation score. So cross validation is applied at the validation stage where we are providing unseen data to the model, and your data is predicting the output right here. So how much accuracy you are achieving? Somewhat 82% accuracy you are achieving right here. Okay, and in the training phase it start from 60%, and it will goes up to 98%. Okay, so training time, training, as you can see, training accuracy is higher as compared to the testing accuracy. So you need to apply some parameters, okay, to this particular data set and model, and you will improve this accuracy. So using create underscore model, you will use the keyword RF. RF stand for random forest model, and we will set verbose equal to true, so it will not give you runtime output. And here you you will see verbose is false. When you put this verbose equal to true, it will show you the runtime output. If you will put this verbose equal to false, it will not give you the runtime output. Okay, so verbose, that's I'm explaining. You initially I have set it false. That means it will not show you the runtime output. You will change it to the true. Okay, you will see the runtime output. Okay, after that we are plotting this model with the help of this RF model, and we assign the keyword as a feature. Okay, so it will show you the important features of your model. Okay, so initially I have set this was equal to false. That means you can see right here it is not showing the output. It will directly show the final output. Okay, so if I will use this verbose equal to true. Okay, if I will use this verbose equal to true, then you will execute it. You will see the runtime output is appearing right here. Okay, runtime output is appearing right here, and after this runtime output you will get the final output. Okay, so to remove the runtime output, we have set this verbose equal to false. So here you can see these two are the important features for this particular random forest. Okay, RM and instant. Okay, and after this we will use the feature importance for extra tree regression. So how you will use the extra tree regression? I have given you the short form of extra tree regression as ET, and just replace this random forest RF with ET. Okay, and plot the important features of this particular model. Okay, so after performing this you will see the output, which column is showing the maximum value. This RM and instant uh, stat is showing the highest variable importance. So right here you can also observe, and third one is your decision tree. So what is the name of this variable which we are defining for decision tree? We are using dt. Yes, we'll replace this et with dt, and we will execute this line of code, and you will find similar outputs right here, but instant stat is somewhat lower importance, but RM is the maximum importance for this particular variable. Okay.